Color feels emotional. Blue feels calm. Red feels warm. Black feels empty. But in space, color isn't decoration. It's physics. Look up at the sky on a clear day, and the first question almost everyone asks is simple. Why is it blue? Sunlight looks white, but it's actually made of every color. When that light enters Earth's atmosphere, it hits tiny molecules of nitrogen and oxygen. These molecules scatter short wavelengths of light much more efficiently than long ones. Blue light is scattered in every direction across the sky, while red light mostly passes straight through. So no matter where you look during the day, you're seeing blue light coming from all directions. The sky isn't blue because of the ocean. It's blue because of air. If Earth had no atmosphere, the sky would look black, even in the middle of the day. And that's exactly what astronauts see. Which brings us to the next question. If the universe is full of stars, why is space black? In space, there's almost nothing. No air, no dust, no particles to scatter light. Light from a star travels in straight lines. Unless that light enters your eyes directly, you don't see it. So even near bright stars, the space between them remains dark. Space isn't empty of light. It's empty of anything that would spread that light around. Now let's talk about the most familiar object in our sky. What color is the sun really? From Earth, it looks yellow, sometimes orange, sometimes red at sunset. But in space, the sun is white. Its light contains all visible colors in nearly equal amounts. Earth's atmosphere scatters some of the blue light away before it reaches our eyes, leaving the sun looking warmer in color. Photos taken by astronauts outside the atmosphere show it clearly. The sun isn't yellow. Earth makes it look that way. The same physics explains sunsets. As the sun drops toward the horizon, its light travels through much more atmosphere. Almost all the blue light gets scattered away before it reaches you. What remains are the longer wavelengths, reds, oranges, and pinks. When there's dust in the air, or ash from wildfires or volcanoes, sunsets become even more dramatic. You're watching sunlight being filtered by an entire planet. And this brings up another common myth. If the sky is blue, why is the ocean blue too? Water is actually clear, but it doesn't treat all colors equally. Water absorbs red light very efficiently. As sunlight penetrates deeper, reds disappear first, then yellows and greens. Blue light survives the longest and scatters back toward your eyes. The sky does reflect off the ocean surface, but that's only a small part of the effect. The ocean isn't copying the sky. They're both obeying the same laws of light. Now let's leave Earth. Look up at the night sky and you'll notice stars aren't all the same color. Some appear bluish-white, others orange or red. This isn't artistic, it's temperature. Blue stars are extremely hot. White stars, like our sun, are moderately hot. Red stars are cooler by stellar standards. There are no green or purple stars that human eyes can see. Even though stars emit many colors, our vision blends them together. Color is limited, not just by physics, but by biology. Planets have stories too. Mars looks red because it is red. Its surface is rich in iron oxide, rust, ground into fine dust. That dust coats the planet and fills its atmosphere, tinting everything. But here's the twist. On Mars, sunsets are blue. The fine dust scatters red light away, allowing blue light to dominate near the sun. Same physics, different planet, different result. Now let's talk about the images that made people fall in love with space in the first place. Nebulae. They look like cosmic paintings, pink clouds, blue wisps, golden filaments. And the question always comes up, are these colors real? Yes, and also no. Nebulae are made of gas. Different gases glow at specific wavelengths when energized by nearby stars. Hydrogen glows red. Oxygen glows blue and green. Sulfur glows yellow. Many space images also include light our eyes can't see, like infrared and ultraviolet. Scientists assign visible colors to that data so we can study it. The colors aren't fake. They're translations, like turning sound into an image. The beauty is real, but enhanced so the universe can explain itself to us. Then there's another confusion. Why do space photos look colorful while space looks black to astronauts? Cameras can collect light for minutes or hours. Your eyes collect it for fractions of a second. In low light, human vision loses color sensitivity. Cameras don't. A long exposure reveals faint colors your eyes simply can't detect in real time. Space hasn't changed. The observer has. And that leads to the deeper truth behind all of this. Color isn't an inherent property of the universe. It's what happens when light interacts with matter, and when your brain interprets the result. Change the atmosphere, the dust, the temperature, or even the eyes doing the looking, and the universe changes color. Space doesn't look the way it does to impress us. It looks the way it does because of physics. And once you understand that, the universe becomes even more beautiful. Thank you for watching.